Okay, so now we're going to start adding things called phase shifts. Now, the problem with this is since these graphs are periodic, if you phase shift it in a certain way, the graph will look exactly the same. Okay, so we do need to be very careful with phase shifts. They can be a bit confusing, I will grant you that, but you can get used to them. Okay, so a phase shift is simply a left and right shift. Okay, so what they're going to do is they're going to look like this. So we have our amp. Okay, now there's two ways to write them. We can write them inside parentheses. Okay, or we can write them outside parentheses. I will work with inside because that is what Edgenuity does. Now the negative in here means that you switch directions. You always go opposite. So it's just like a parabola. If you can remember that far back. It was a long time ago, wasn't it? All right. So a negative will result in a positive or right phase shift. Okay, and a positive will result in a negative or left phase shift. Okay. All right, so let's just do a phase shift. I'm not even going to do a period change yet. We're just going to do a phase shift. Okay, let's keep it simple. Let's just do sine of x minus pi over 2. Okay, so that tells me that the amp is still 1. Period, no change. Okay, because there's a 1 in front of your x, so 2 pi. And then the phase shift is positive pi over 2. So my graph is going to shift pi over 2 to the right. Okay, here we go. Now, if we were in class, like an actual physical class, I would tell you about the importance of colored pencils and being neat and labeling your graph. Okay. Also, I tend to irritate students because I tend to do a little bit more work than some students think is necessary for these, but it helps me see what's going on. Okay, so I'm just going to do my standard markings like I normally would. Okay, so this is sine. So there's my positive side. Oops, I'm a little off there. Can't get rid of that one. Just one dot. Oh no! Over rambunctious with the erasing again. Makes you miss pencils. Okay, get rid of that. Okay, so that's the positive side. Now I'm going to do the negative side. Now, for those of you who are sitting there like, why would I do this by hand? I have Desmos. You can set up Desmos to do these, and you can label them with the pi over 2 and the 3 pi over 2 kind of labels on that. You don't have to use 1, 2, 3, 4, 5. Okay, so let's label. So this is 2 pi, 3 pi over 2. Okay, now you will notice that each of my tick marks conveniently is pi over 2. So if I'm going to move this thing to the right, okay, I am going to move everything to the right one tick mark. Okay, so this right here is my parent graph. And now what I'm going to do in another color is just move everybody over pi over 2. And there we go. Now I kind of go beyond like that. And that is phase shifted. Okay, so the different colors kind of help me see what's going on. Okay, and that's how you do a phase shift. Okay, let's do something a little bit more complicated. Let's do a cosine. Let's do an amp change. Let's do a period change. Okay. Oh, let's make this left. Okay, so that looks awful, doesn't it? Okay, so I know my amp is 2. Okay, now my B is 1/4. So that means my period is 2 pi divided by 1/4, which is 2 pi times 4 over 1, which is 8 pi. So it's a very wide, very long. Okay, so now how you find a phase shift, okay? Is you're going to go your C, okay, your addend on the right, divide by B. Okay, if you look up here, right? Okay, now I always tell students to figure out the sign first. So it's positive here. So I know it's going to be opposite of whatever I've got. So my phase shift is going to be negative 4 pi divided by 1/4, which is 4 pi times, negative 4 over 1, 16 pi. Oh my goodness. Okay, it's a huge phase shift. Okay, so we can do this. This is going to be a fairly, kind of large graph, at least for me. Okay, all right, so what I'm going to do is I'm going to give myself plenty of room. Okay. All right. Now remember, I want to be able to see what's going on. Okay, so I'm going to start with just my tick marks. Okay, cosine. So cosine starts up here. And again, I am really into using different colors with this so I can see what's going on. There we go. Okay, so now, again, remember these graphs are periodic, they continue. You should probably put arrows on the end, but that's okay. Let's go. My amp is now 2. So 2 and -2. All right, one full period is 8 pi. So this is going to be 8 pi. And so divide that by 4. So each one is going to be 2, 4, 6. Okay, so now I have to shift everything right 16 pi. So, oh goodness, I need to put some more tick marks so I know what's going on. So notice that each of my tick marks is 2. So I'm going to do this. So now I'm going to go 10, 12, 14, 16 pi. Okay. Now if I really, really wanted to do everybody, okay, I would have to extend it out even more. So let's see. 16, 18, 20, 22, right? Okay, so, but I'm just going to do it until I run out of room. So this guy on the far left gets shifted 16 pi. See, he's negative, so he would actually move over here. Okay, this guy is -6. If I'm going to move that 16 pi, that would be moved to 10. Okay, -4 would be moved to 12. And then follow the pattern. So this pink graph is my actual phase shift. Now notice how that just kind of looks the same. So depending on what your phase shift is, depending on what the period is, the graph can actually just look like a continuation of what you had before. Okay, so in the next video I will try to post, we will put it all together. We will do phase shift, we will do vertical shifts, we will do period changes and amplitude changes, and we might just for fun throw in some reflections. Okay, all right.